All right. Welcome back, wonderful people. So what we're doing today is we're going to solve and graph inequalities. Graph inequalities is compound inequalities and solve and graph and and or problems. Actually, for today, we're only going to be focusing on this first objective here. And that's pretty much it. So I'm going to break into 2 lessons if I have to. So what you would use for solving inequalities. So to graph them, there are 2 ways that we can show this. So we call this a closed circle. So I'm just going to come up with a really quick example. You might remember that there are exercises where you would have to use a number line, and there might be some numbers on this number line. So like, for instance, I'm going to pick, say, -2. So if I want to have a number, so x is, let's say, greater than or equal to -2, I would mark it with a closed circle, like a door. Okay, if you can imagine a door, this door is closed. So if you tried to go through it, you would basically hit the door and stay there. Now this also tells me that we can pick it because it has these or equal to signs. So like if I were to try to pick -2, it would look something like -2 is greater than or equal to -2, which is true. And that's why I'm able to pick -2 itself. Now there's also another step, and that is I need to find out which way this is going to go. So we have a marker, and it can either go to the right or it can go to the left. So we need to find out which way it's got to go. So in this case here, if I say x is greater than -2, I want you to think of a number that is greater than -2. Okay, now you probably didn't pick the exact number I'm thinking of, but maybe it would be something like 4. Well, 4 would be over here, so I'd probably pick 3. Yeah, 3 works out as well. So if I pick 3, 3 is greater than -2, right? So 3 greater than or equal to -2, that's a true statement. And this arrow points to the direction that makes it true. So we want a solution that will basically, anything I plug in there, again, anything that's greater than -2 should work out. Now, even if I pick -1, that's also true. That should work out. If I pick 10, which would be over here somewhere, that would also be true. So that's basically how you do a graph. And then I'm going to make another example. So with an open circle. So I'm just going to make up another example. I'm going to say x is less than, let's say I'm going to make this one 0, and I'm going to go with 3 just because I used 3 in the last one. I would use an open circle, like an open door, right? If a door is open, you can see what's behind that door, what's inside or outside of that door. So in this case, I can see what's behind it. Now, just like an open door, I cannot land on that door. If I tried to go through the doorway, I would go right through. So in this case, if I pick 3, I can't pick 3. And if I put 3 as x, I run into a false situation. 3 is less than 3. And that's false, because if you had $3, you can't say that this $3 is worth less or more than those $3. $3 is $3. It doesn't matter, what it is. I mean, and I will get sometimes students that will say, well, what if it's a really bad torn up dollar? Well, it's still going to be accepted. $3 is $3. Doesn't matter how. Now again, to mark it, I need to find out which way it's going to go. So let's see. In this case here, it looks like it's going to go, I need a number that is less than 3. So if I told you to pick a number less than 3, you might pick 1 or 2, which would be true. 1 and 2 are less than 3. But you can also pick negative numbers like -1, -2, -3, -4, all the way to actually -infinity. And if I pick anything in there, like I said, 1, actually, I'm going to pick -1. -1 is less than 3, that's going to be true. And this one's also true here. But again, I'm just showing you how you use these symbols now. Sometimes I might use the words like hollow or filled because that's kind of the way I've been using it for years. I actually don't use the open and close very often. So sometimes you might hear me slip and I'll say filled or hollow. So I'm trying to stick with the vocabulary that they use in this lesson here. So just to let you know. Now, in this case here, we have one other thing that we need to do, and that is interval notation. So I'm going to use these exact same examples already. So interval notation is a way to write the solution of an inequality using infinity symbols, parentheses, and brackets. So this also, parentheses are used with open or no or equal to, so less thans or greater thans without the or equal to. So if you use the hollow circle, that's the time you would use parentheses. So now with these, you have to start from left to right. So the leftmost number, remember how I said that this number goes to negative infinity. Well, starting from the left, it actually comes from negative infinity. So the smallest number I can pick, well, I can't pick it. So that's why I'm going to have to use a parenthesis. So from negative infinity to 3, and I'm going to have to use a rounded bracket. Sorry, parenthesis. Well, parentheses are naturally rounded, so it's going to be just 3. So anyway, that is how you would write this in interval notation using brackets. In this case, that we have the or equal to. So again, it depends on what kind of inequality you have. In this case, if you have the less than or equal to or the greater than or equal to, you're going to use a filled circle, which again is the closed circle. And if you use those, you're going to have to use the bracket. So let's go ahead and start from here. So starting from left to right, the lowest number that we have is -2. And we can include it. It is included in the set. So -2, and it goes on to positive infinity. And those are the numbers that we would have. But anyway, that was just an example. Let's go ahead and go on to some of the exercises where we're going to have to use this. So let's go ahead and do a really quick graphing of inequalities. In this case, in these cases, it's already solved. We don't have to do anything. But they want us to graph out x is greater than or equal to 8. And they give us a little graph here to work on this. So I'm going to go ahead and work on that by putting I'm going to put 8 in the middle. Now, you don't have to put them exactly in the middle, but you must include them somewhere on your number line. So I'm going to put 8 in the middle, again, just to keep things simple, and put some numbers onto the side of each of those. Now, I'm also going to have to mark out 8. So look at the kind of inequality we have. We have x is greater than or equal to 8. Now you also read these from left to right. So going from left to right, first thing I read, just like reading a book, x is greater than, because that mouth is open towards the number that I just read, which in this case is x. X is greater than or equal to 8. And this is kind of like half of an equal sign. It's like the bottom half of an equal sign. So in this case here, we need a closed circle, because in this case, I can pick 8. If I pick 8 is greater than or equal to 8, that's true because it says or equal to. Now I need to point out which way it's going to go. So now, reading it, x is greater than or equal to 8. So pick a number greater than 8. Chances are you picked 9 or 10, which in this case, that would tell you you can go this way. But again, if you're not sure, pick a number. Like in this case, I picked 10. 10 is greater than or equal to 8, which this is true. So this means that it's going to point this way. Now I'm also going to warn you as well. I'm going to warn you because some students they think they've discovered a shortcut. And the shortcut usually has to do with using this thing to tell which way the line is going to point. Now I'm also going to tell you that's going to be false. That doesn't always work. Okay, so it's just like using PEMDAS, just like PEMDAS. It works 9 out of 10 times, but it doesn't work every time. There will be cases where you can run into something that doesn't work. So the best way to do this is to plug something in and see if it works. If it balances out into a true equation or a true inequality, then that's what makes it work. So again, don't use shortcuts. And I'm not saying it just because I want you to do more work or work harder or anything like that. It actually doesn't work sometimes. And I see it happen all the time, so be careful of that. All right, so using interval notation, let's go ahead and put it in. So again, starting from the left, coming to the right, the first number we meet under the line is going to be 8. Now again, this one is included, so I'm gonna go ahead and put 8 with a square bracket. And this goes on and on to infinity. So if I ask you to pick a number greater than 8, you could pick something like 9 or 10, or you could pick something like 50, 100, 1,000, 1,000,000. There's really no limit. Now we can't include infinity because as soon as you think of the highest number you can count to, just add 1 to it and now you have a new infinity. And it just goes on and on like that. So in this case here, we're never going to reach infinity itself. So, oh well. Anyway, we're done with this one. So now we have a new one here. So we have A, and A is greater than, wait a minute, greater than? No. Looking at the mouth, it's facing away from the A. So A is actually going to be less than -1. So that's the way you would read it. A is less than -1. So I'm going to just put -1 in the middle. And then I'm going to fill in numbers both left and right to it. And here we're going to have to use an open circle because we cannot land on it, right? It's like an open door. If I try to pick -1, I'm going to go right through it and fall downwards, okay? Now, if I pick a number on this side, so let's pick 1. If I say 1 is less than -1, is that true? Think about it. Would you rather owe, or would you rather have $1, or would you rather owe somebody $1? And they're not going to be the kind of people that forget either. In this case, it's better to have $1 than to owe $1. So in this case, this is false. And remember that a negative number is always less than positive numbers, and positive numbers are always greater than negative numbers. So this is not false. I'm sorry, it is false. Ah, man, my brain's getting scrambled today. All right, so what about this one? Is this one true? -3 is less than -1. Now this one is true. Oops. That one is true because I would rather owe somebody $1 than to owe them $3. Okay, like in a bank, you know, if you overdraft, that's always bad. It's better to have money than to owe the bank money. So in this case here, since -3 is true, that means that we're going to have to mark this side of -1. So we have everything less than -1. So anything under here is going to be true. So if I put in like -10, that is going to be definitely less than -1. So the interval notation for this one here, now starting from the left and working your way to the right, we have -infinity, which is the lowest number that we can pick. And again, we cannot pick -infinity, so we're going to use a parenthesis. The highest number we can pick is -1. Now in this case, -1 is not included because again, we cannot pick a negative number. Now, what if I were to pick something like, say, -1.1? It would be a little bit on this side, so it would actually be true, but I cannot pick -1 because if I pick -1, less than -1, this is false. Okay, that would be a false statement. because I cannot pick that number. And that's why we use the open circle, because we cannot pick that number. Again, if it's like a door, you can't pick it because it's open. All right, moving on. Now, for solving inequalities, you would use the same rules as you would use on an equation. So that's what we've been working on for the past, well, last week we worked on equations. And everything's the same. You still have to do the same thing. So that is get rid of parentheses or groups. That is the first thing you do. The second thing you do is pick a side. Wait, hold on. Yeah, pick a side for the variable to go on. Move the variable to one side, and then you have to do the addition and subtraction so that you get the x by itself. And then you would do the multiplication and division. Now again, there are some switches, some changes to that rule, but it's largely the same. But there is one difference that you would have to watch out for, and that is this rule here. This is the exception. You have to switch the inequality symbol if you multiply or divide by a negative number. So multiplying or dividing by a negative, you are going to have to switch the sign. So if you have a less than, it will change to a greater than. If you have a greater than, it will change to a less than. So you will flip the sign. Again, that's the only one that you really have to watch out for. And, you know, I'll go ahead and mark this as important, because it is important. All right, so again, everything is the same as solving equations. The only difference is this thing here. Well, I think there's like one or two more differences, but largely solving the problems themselves is pretty much the same. All right, so let's go ahead and practice using some of these. All right, so again, just treat this like an equal sign. All right, just in your own mind, ignore that and just treat it like it's an equal sign. So just, you know, I know this thing can be kind of, what's not confusing, but like scary, but not really scary. It can be intimidating a little bit, because I will see students that say, how do I do these things? Well, okay, just pretend it's an equal sign. So let's do the same thing we would normally do. So we take care of parentheses. Now we got to pick a side for the variable to go on. So here I have a couple of choices. I can minus 5v from both sides, but actually I don't want to do that, because then my v is going to be on the right side, which we always want it to be on the left side or the first side. When we show our answer, when we show the solution, we have to have it on the right side, because remember, I told you that you have to say what you're solving for. In this case, we're solving for v. So in this case here, now you don't have to do this rule. I'm going to show you another way to do this in a minute. Well, later on in this lesson, but I am going to minus 7v. And that's going to have the effect of moving the v to the left side. All right, so now they do the trade, right? One side wants the variable, the other side wants the regular numbers. So in this case, I have negative 2v is greater than negative 18, because I'm going to combine these two together to make 18. Negative 17, negative 1. Now I have to get rid of this negative 2. So remember, when I divide, it's not enough to just divide by 2. I have to get rid of the negative as well. And this is the part you got to watch out for. These negatives, okay? That's the thing that you got to watch out for. So I put an exclamation mark there. So again, you got to be careful on these. You got to be vigilant. And make sure that if you see a time that you have to divide or multiply by a negative, in this case, you change the direction of the sign. So you see how it was open towards the left? Now it shall be open towards the right. So now we have a number v is less than 9. Now, we should check it, okay? And again, you can check it pretty easily. So let's plug in v is 9. So this is 5 times v. So 9 times 5 is 45. Plus 1 greater than, and then 9 times 7 is 63. Minus 17. 46 is greater than, and then let's see, 63 minus 17 is 46. Now in this case, it comes out to be balanced. So actually we don't want something that is equal, because in this case, it doesn't tell us anything. So let's pick 8, or actually, you know what, let's pick an even easier number. Let's go with 1. So v is 1. 1 times 5 is 5, 5 plus 1. 7 here, so 7 times 1 is 7, minus 17. So we have to pick a number less than 9. Now, if this is true, that means that our line should be pointing towards the numbers less than 9. So in this case, I got 6, and then this would be 7 minus 17, that'd be negative 10. And in this case, again, we have a positive being greater than a negative, which is true. So again, this means definitely that this line should be pointing this way. Okay, v is less than 9. So if I pick something less than 9 and plug it in, it should make this true. And that's how you test it. Okay, don't pick the number itself, because that's how you check an equation. So pick a number that is, you know, what it tells you, less than or greater than. Now, if I did not flip the sign, I would pick something like 10, and I'd plug it into this, and it would be false. So again, that's how you check it. Let's go ahead and put it into interval notation. So from negative infinity, working our way to the right. So starting from the left, working our way to the right. Negative infinity is where it begins at, and the highest number that it goes to is 9, which is not included because we have an open circle. And there is no or equal to, so I cannot pick 9 itself. Okay, so that is it for number 3. Let's move on to number 4. So again, same rules as solving an equation. First thing we got to do, get rid of our parentheses by distributing, or any groups for that matter. So if we have a like a fraction bar or an absolute value, we would still take care of that first. And also, don't forget that this is negative 3. So anything you multiply by 3, you're going to have to multiply it by the negative as well. So don't do something like this. Okay, in this case, I made this error because this would be negative. Wait, I tried to make the error, but I didn't. But we would get something like positive 27. No, you got to times this by negative as well. Okay, so that's going to be negative 3 times positive 9 is going to be negative 27. Now, combine your like terms on both sides that are alike. So in this case, I have 21x minus 15x, and that would be 6x. And actually, while I'm at it, I'm also going to add 27 to both sides. So 7 plus 27 would be 34. And now that we took care of the addition and subtraction, let's go ahead and do any multiplication and division that we need to worry about. So in this case here, I have x by itself, but we end up with this weird thing here. So let's go ahead and remember, if you can't, well, actually in this case, we can divide it because 34 is a bigger number. But I'm going to turn this into a mixed number just because, again, I always want to do fractions whenever I can. So this would be 17 over 3. So I reduce it. Divide this by 2 and divide this by 2. Now in this case, we have to graph it on our number line here. So where is 17 thirds? See what I mean? It's a little confusing. So what we're going to do is we're going to divide it. Now, you probably could use a calculator, but again, I want to use fractions whenever I can. So how many times does 3 go into 17? So 3, 6, 9, 12, 15. Now I can't go higher than 15 because if I go the next number up, it's going to be 18, which is going to go above 17. So 5 is what it is. And I counted to 15 because 3 times 5 is 15. 17 minus 15 is 2. So that means there's going to be 2 left over. Bottom number does not change. So this is going to be 5 2/3. I'm going to pick the next highest number. Sorry, not the next highest number, but the one of the closer ones. And it doesn't have to be in the middle because remember I told you this, the number that you compare it to doesn't have to be in the middle. But in this case, it just sort of worked out that way. Now, a third means dividing something by 3. So, you know, if you bought a pack of Skittles with 2 of your friends and you decide to split it 3 ways, you know, you'd probably try to get a nice way to divide them by 3. You could count them out or just go by size or whatever. But anyway, I'm going to take the number between 5 and 6, this interval, and I'm going to split it into 3 sections, 1, 2, 3. And I need the second one, so 2 out of 3. And in this case, I'm going to use a filled circle, the closed circle here. There you go. So now I've marked it out on the number line. Next thing I need to do is pick a number that is, well, okay, let's look at it. It says a number x that is greater than 5 2/3. So if I told you to pick a number greater than 5 2/3, you'd probably pick something like 6 or 7. And you can check it too. Let's check it to make sure it works out. So if I plug 6 in here, it should work out. Yeah, it should work out. Okay, I'm pretty sure of it. Let's go ahead and put it in an interval notation now. Again, I would suggest you check as much of your problems as you can because sometimes there are times when things are going to be a little bit different. Now, starting from the left to the right, I have nothing until I get to 5 2/3. But it is included, so if I pick 5 2/3, it will balance out because again, we do have the or equal to, which means I can pick it. And this will go to infinity. So that is it for interval notation. So 5 2/3 all the way to infinity. So I can pick anything as long as it's bigger than 5 2/3 or even equal to 5 2/3. So I can pick something like 7, 10, 14, 53, anything up to 1,000,000, billion, whatever. As long as it's greater, then it should always be true. All right, so I'm going to go ahead and move on to the next one. Now we have more solving to do. So we got more solving. And for some reason, they just really like, excuse me, parentheses in this. So nothing's going to change here. All right, but I want to get rid of these parentheses here. That's always the first thing we got to do is get rid of any grouping symbols or parentheses that we have. So don't forget to multiply everything by -2. So -2 times +4. And here I have -2 times -2. So again, that's usually one of the big things that usually goes wrong when I try to go through these lessons and I'm checking work. This is one of the bigger things that goes wrong. All right, now we took care of the parentheses. So let's look for like terms. I have no like terms on either side. So now we have to pick a side for the variable to go on. Now I could either minus 12p from both sides, which would actually make it negative and on the right. So that's bad. So the better option would be to minus 4p from both sides. Now you don't have to do it this way, but it is definitely easier to do it this way. And simpler too. And something that is simpler is less likely to have things that go wrong. So keep it simple. All right, here, since I got rid of something on this side, I have to get rid of something on this side. So now they each trade away something that they want for something they don't want, or they trade away something they don't want for something they do want. 12 minus 4, so 12 minus 4 is going to be 8p. Now we did some subtraction. Subtraction will not cause this mouth to change direction. It will not switch the inequality, okay? So don't get all flip happy and start flipping everything off. Flipping it around. All right, don't be flipping that inequality sign just for anything, okay? You gotta make sure it's only when you multiply or divide using a negative. That is the only time that you're gonna have to do that. Now, here I have a negative 60. And this looks like it's gonna be another fraction, maybe. And just to make this one a little bit simpler, I'm gonna go ahead and divide both sides by 8. And I would hope that you don't use a calculator for everything, all right? Because again, I do want you guys to learn fractions because that's usually one of the biggest things that happens. Now think about how many times 8 goes into 60. So if we divide it, how many times does 8 go into 60? Or you can divide it using long division. So hopefully you remember how to do long division. Actually, I'm not even sure if you can, let me do it down here. So 8 goes into 60 about, let's see, 5, 6, 7 times. 8 times 7 is 56. And that means I'm gonna have 4 left over. This becomes my top number, 4. Bottom number, if we look at the where it is down here, 8 is still my bottom number, so that's gonna be the bottom number here. Now I'm gonna reduce this 4 over 8 because, well, they can both be divided by 4. So 4 divided by 4 is 1. Oops, gotta write the whole number. And 8, the bottom number, can also be divided by 4, so that would be 2. So we would have 7.5. And this is an example of where it's better to have a mixed number than a fraction. Because if we left this as a fraction, it would be something like 15 over 2, which doesn't really tell us much. Well, it would tell us that 15 divided by 2. And if we use that on a calculator, it'd be 7.5. But either way, this works out. So let's go ahead and include 7, 8, 9. And then we have to go down. So pick a few numbers down. And 7.5, well, it's exactly halfway between 7 and 8. Well, that's what a half means, right? It means halfway between those two numbers. Now we need to find out which way is going to be marked. And again, don't use any shortcuts. Definitely plug something in. Now read it to yourself. P is greater than 7.5. So pick a number that is greater than 7.5. And we have a few of them right here, but you could pick something like 10. 10 is greater than 7.5. And since 10 is on this side, that means we're going to have to mark all the numbers on this side. And if we pick 9 and plug it back into the equation here, so 9 for P, or it'll probably be easier to pick 10. In fact, let's go ahead and do that really quick. So 10 times P, or 12 times 10 is 120 plus 52, greater than negative 2 plus, or sorry, times 4 minus 20. And you know, if I keep going with this, I get 172 is greater than, let's see, 4 minus 20 would be negative 16. Negative 16 times negative 2 would be 32, and that's true. So that means that this is going to be true. And again, I would suggest you check more things, but you know, if you're pretty sure you did it right, then I wouldn't worry too much about it. All right, so lowest number we can pick. Lowest number, well, we have an open circle, so it's going to be a parenthesis, 7.5. And then largest number we can pick is infinity, because that just goes on to infinity. Ooh, shoot. You know what? This should actually be negative 7.5. I almost lost the negative there. That's why it's a good idea to check your work really quick. Now, luckily, it still works. Nothing really would change all that much. I just need to change the numbers on the graph. My bad. Sometimes I get carried away explaining things and not actually checking what I'm supposed to be doing. So yeah, you guys were supposed to catch that. Anyway. All right, so here I have this negative, and don't forget, when you have a negative, you can think of it like -1. Distribute the negative, or remember that you are subtracting everything in this group. So that means we're subtracting the 4m, and we are subtracting the 1. Combine your terms on both sides. So I have regular 3 and a -1. So I'm going to go ahead and put those together. 3 minus 1 is 2. And now I took care of everything, so I shouldn't have any like terms on the same side. Let's pick a side for the variable to go on. Now, again, we have that choice here. And I'm going to go ahead and use the rule again. So remember, if we multiply or divide by a negative, we have to flip the sign. And in this case, if I add 4m to both sides, oh, well, actually, you know what, let me stick with what we're supposed to be doing. I'm going to have to minus 5m from both sides. Now, I'm going to show you another way you could do this. It's not easier, okay? It does have its own drawbacks. It's not perfect because with problems like this, there's no, straight to the answer. There's no easiest way that is obvious, okay? So you got to be careful with some of these. Now, I'm going to show you that trick after this here. So let me go ahead and have both sides do the trade. So now here I should have negative 9m greater than negative 27. Now again, this is the part you got to worry about because I am dividing both sides by negative 9. That's the part you got to watch out for. That's the part where you should have some alarms in your brain saying, hold on a minute, you should not have to divide by negative 9 or any negative number without flipping the sign. So now I have to flip that sign. So now it was open towards the left, now it's open towards the right. Negative 27 divided by negative 9 is 3. So this should be our solution. Let me box this solution too. Did I box my last ones? Nope, I actually did not. And remember, I like to box the solutions so that we have the solutions boxed, so it's really easy to tell where it is, especially when you have something like this. You just see that it's just kind of chaotic. There's a lot of stuff going on. I think the packet itself gives you a little bit more space to write these things, but if you ever, fill up the space that you have to work on the problem, then it's always good to put the box here. That way I know it's your final solution. Like in that one show, Who Wants to Be a Millionaire? Is that your final answer? Anyway, m is less than or equal to 3. So since it can be equal to, I'm going to use a filled circle. And m has to be less than 3. So pick a number less than 3, or again, pick something. If I pick 1 less than 3, that's true. So that it means it's going to go this way. Interval notation, so lowest number we can pick is negative infinity. Highest number is going to be 3, which we can pick. So I'm going to use a bracket to show that it is included in that set. So again, anything from negative infinity up to and including 3 is a solution, which actually means that there's multiple solutions for these kind of problems. All right, so moving on, let's go ahead and move on to question number 7. So again, we got to follow our steps. First thing we got to do is get rid of these parentheses. 3 times 8. 8, 16, 24. So yeah, 24x minus, and then it's positive 3 times negative 9, so that'd be negative 27. 4 times 6 is, let's see, 4, 6, 12, 24, so that'd be 24x plus 4. And again, don't forget to distribute that 4 to both of these. And remember, after we look for like terms, we got to pick a side for the variable to go to. Now, there's a reason I tell you guys to look at the variable first. Because in this case, you might notice that there's a weird occurrence. There's something strange going on here. If I minus 24, trying to cancel either side, I'm going to have negative 24 on both sides, and that's going to cancel both x's. So in this case, I lose my variable. Now remember, I told you there are 2 things that can happen when you lose the variable. There is either no solution, which is the first thing, and the second thing is going to be all real numbers, or sometimes we call it infinite solution if it's graphed. So how do we determine whether it is all real numbers or no solution? So the rule is the same. Check the equation, or in this case, the inequality. Is it true? If it is true, then it shall be all real numbers. If it is false, then it is no solution. So is negative 24 greater than 4? And this is a big false. It's not true. So that would mean this is no solution. So no solution. Now I cannot graph this because I don't have a middle number. You might be saying, well, wouldn't negative 27 be your middle number? No. Well, why not 4? Right? Neither of those are included. There's nothing I can put in this x that will make it true. It's always going to be pointing the wrong direction. The mouth will open towards the smaller number or the lesser number. So in this case, there's no solution. I can't graph it, and I can't put it in interval notation. So I'm going to leave those blank and move on to the next one. All right, so let's distribute the 10. And 9 times 8. Pretty sure I feel like I know this one, but I'll go ahead and double check myself. All right, and check the signs, make sure I didn't lose any signs or, not distribute everything. Sometimes I'll make a mistake sometimes. I won't lie. 10 minus negative 13, or sorry, 10 and negative 13, or 10 minus 13. That's going to be negative 3a. And now I have to move the variable to one side. Now remember, I always say that it's best to move it to the left and keep it positive if you can. But in this case, it looks like we will not be able to do that. I cannot move it to the left and keep it positive, because if I tried moving it to the left, it would be negative. I'd have negative 12a right here. Now, remember how I said that I'm going to show you another way you can do this? Now, it's not any easier, but there is a little bit of a benefit, and that is you don't have to remember the rule. So imagine this, you're taking a test maybe a year from now, or even a few months from now, or even next week. And you're just sitting there thinking, man, I knew there was something that was supposed to go on with this inequality, but what was the rule? Well, in that case, what you should do is work to keep it positive. Keep the A positive. And again, this is not a better way. And because it's not necessarily a better way, I'm going to switch between the two. So I'm going to alternate. I'm going to alternate between using the negative rule and keeping it positive. So, oh, why did I pick 2? I don't know why I picked 2 there. Because I need to get 3 to get rid of this -3, and that's going to cancel it here. And you notice that it's not on the left side anymore. And this will have its own effect. So in this case here, I'm going to end up with, let's see, 12A here. And I think this would be 42. Okay, oops. Yeah, it would be 42. Now this one's a bit of a weird one because A is on the right side, and the regular number is on this side. Now, I still got to get rid of this 12. Now, to do this, again, I'm just going to use division. So 12 divided by 42, and you can simplify this before working on it. But again, just dividing it. So how many times is 12 going to 42? So 12, 24, 36. I think 36 is the closest number we can get, which would be 3 times. I can fit it in there 3 times. And let's see, 42 minus 36 is going to be 6. And again, 6 becomes the top number, 12 becomes the bottom number. So bottom number stays the bottom number, okay? And we simplify the fraction. So in this case, we have 3.5 is less than or equal to A. Now, we're not done yet, because anytime we have a solution, and I said this during solving equations, I said you have to have the variable you're solving for first, because that's just how English works. Okay, in the English language, we say what the item is and then we describe it. The calculator is the black and gray buttons. The mask is blue. Okay. You know, we describe that. This person is tall or something like that. We always say what we're talking about first, and that's what we should do. We should say the A is okay. So what's going to happen here? So I got to put the A on the first side, but now I have to do this. I'm going to flip it. I'm going to flip everything. Just imagine that the whole thing's going to get mirrored. Okay, everything's in reverse order now. So A is switching to this side. It's on the first side. Now, pay attention to this because this is important. This is the rule that you have to remember if you're going to use this method. Like I said, there's no freebies here. The mouth is open towards the A. When you flip the direction, when you flip the sides, it should still open towards the A. See, the mouth is still open towards the A. So everything got flipped, the direction of the A and the direction of the inequality's mouth. And it's facing away from the 3.5. So that's how you flip the whole thing. Okay. Now again, you could do the opposite. You could have minus 9A on this side, but you would still have to flip the sign. Okay. So again, there's no real easier way to do this. I don't think there's an easy way. And again, I think both ways are very good and you should really learn both ways. So that's why for this, I am going to be switching between both of them. I'm going to be switching between using the negative and keeping the variable positive, as I call it. Keep it positive or remember the negative rule. Anyway, 3.5, that's halfway between 3 and 4. So I'm going to mark it there. Okay, now I got to find out which way it's going to go. So left or right? And again, pick a number. So 5, if I pick 5, 5 is greater than 3.5. Yep, that's true. And if I pick something that's false, okay, let's say I pick like 1 and it turns out to be false. There's only 2 directions this arrow can go. If this side is false, then the other side must be true. And the same is true if something points in the other direction. In fact, maybe for the next one, I think I just have a habit of picking the right one. But I'm gonna try to pick the next one as being obviously false, just to show you what happens. All right, so starting from the left, so again, interval notation, start from the left, work your way to the right. I have 3.5. And it is including 3.5, right? 3.5 is included. And this goes to positive infinity. And we have our parenthesis, because again, you cannot include infinity. Just can't happen because it's constantly gonna work to keep itself out of your reach. And there we go. So we're done with that one. Let's go ahead and move on to number 9. All right, looks like we got more stuff going on. Whew, man. And let's see. Now remember, everything gets multiplied by -7 here. So -7 times 2 is -14r. And again, -7 times 3 is -21. So you got to watch out for those negative signs, okay? This one's not so bad because I don't have to change the sign. I'm not using any negatives. Now I need to combine my like terms, which I have 2 like terms. I have 8 and -21. So this is going to be 8 minus 21. It's going to be -13. So -13 minus 14r. Now I took care of the parentheses, combined my like terms. I need to pick a side for the variable to go on. And let's see, this one has the same thing, right? I am going to have to pick one of the options. I'm either going to have to keep it positive, keep the variable positive, or I'm going to have to remember the rule. And again, I said I was going to alternate. So the last time we had a problem like this, I flipped the whole thing because I kept the a positive. Here, I'm going to do the other thing. So I am going to minus 3r. So now I'm going to put it on this side. And again, you might pick one of these that you like better than the other. But you got to remember the rule because each of them has their own rule. So that will cancel here. And here I'm going to add 13. And that's going to cancel that here. So again, both sides have something canceled. So this is going to be -17r. And what do I have here? 13 minus 30. I think that'd be -17. And it looks like I'm going to have to divide both sides by a negative. So again, this is the rule. I divided both sides by a negative, so this means that I am going to have to flip the sign, flip the inequality. So this is r is less than or equal to, oh, hold on a minute. Got to flip the sign. It's opening towards the r now. This one's really slanty. Yeah, works out. So it looks like we got 1 in the middle. 1, 2, 3, 0, and -1. Now let's go ahead and mark it out. So again, we want the closed circle because it is including 1, because or equal to means it can be 1 itself. And I need to find out which way it's going to go. So I need a r value that is greater than 1. So if we pick 3, oh, hold on, I said I was going to let's say I pick 0, right? 0 is greater than 1. That's false. That's not true. 0, would you rather have $1 or $0? I'm sure most of you would rather have $1 than having nothing. So if it's false, it's going to go away from the direction you picked. But again, plug something in. Try not to rely on any shortcuts, because the shortcuts sometimes just don't work. They work a lot, but they don't work every time. And I don't believe in something that works only sometimes. Okay, you wouldn't wear a seatbelt that only works, only works 8 out of 9 times or whatever. You wouldn't want a parachute that has a 1 in 10 chance of not opening. Okay, you wouldn't want to wear a safety harness, when you have to climb something high that has a 1 in 10 chance of breaking. So just don't bother it. Just don't bother with it unless you know really, really well what the rules are. So anyway, let's go and put it into the interval notation. So we include 1 on to infinity. And there we go. That's it. So this line goes on and on for infinity as we go to the left. And again, everything just goes in the direction you read it. So I think a lot of students, they have a tendency to overthink things. But yeah, a lot of these rules are pretty straightforward. Always go from left to right and follow your basic rules. All right, let's go ahead and move on to this one now. Still got parentheses. So with this one here, we got -3 times 2, so that'd be -6p. And don't forget to multiply the negative out as well. So this would be -3 times 8. And -8p. And again, don't forget to multiply the negatives. This is -4 times 6. That'd be -4, 6, 12, 24. Okay, now again, focus on the variable first. I always tell people, look out for the variable first, okay? Don't focus on the number. I don't know why some students want to focus on the number first. So I'm going to add 8p to both sides. That's going to cancel it from here. Now I need to add 24 so I can cancel it from this side. So add 24 to both sides. What's going on with this one here? Because I cancel 24 on this side also. 8 minus 6, okay, that's going to be 2p equals, well, what goes on this side? 0. Does this mean we have no solution? No, doesn't mean we have no solution. Remember, the rule for no solution or all real numbers is you lose the variable. We still have the p right here. The p didn't go anywhere. The variable is still there. So therefore there is a solution, but we have no number. Now what number can I times by 2 to get 0? Okay, if I say it like that, you should probably easily know that, because that is one of the number properties. It is the 0 product property. And that is 0 times anything should be 0. So the only number that could fit in here is 0. Or if I were to divide both sides by 2, 0 divided by 2 is 0. Now you can divide 0, but you can't divide something by 0. Because in this case, it's like if you have 0 Skittles and 2 people, nobody gets Skittles because there's no Skittles to share. But again, in this case, the answer is, the solution is simply 0. Well, I shouldn't say the solution is 0, but it starts from 0. Now, p has to be less than 0. Okay, p has to be less than 0. So pick a number less than 0. And if you picked anything that's negative, okay, you is real smart. Now we got to put it in interval notation. Now that we graphed it, we can look at the graph. Oh, yeah, we could check it too. If we pick 2, 2 is less than 0. That's false. And it's not underneath the line, so we know that the line is pointing in the right direction. So let's go ahead and put it in interval notation. So again, we cannot include negative infinity, but coming from negative infinity, we got to work our way to the right. And the highest number we can reach is 0. And 0 is not included, so we put a rounded parenthesis there. And that should be enough. And it looks like we're done. Okay, moving on. Okay, I think these are the last two in the packet.
Mr. Ness?
Yeah?
Can you go back real quick?
Okay.
Okay, thank you. You can go.
People talking sometimes, that's all. It gets so quiet here. I mean, it's like the building is always alone, and like it's just alone all day. Like there are no other teachers here. So it's always weird when I see somebody. You know, like you can see my classroom, it's empty back here. All right, let's go ahead and get ready to move on down to the last page. So I think that is the last last slide. Well, there's one more, but that one shouldn't be too bad. All right, moving on. All right, let's go ahead and get to number 11. 11x minus 4, 6x minus 3. And again, don't forget to subtract this entire group. So that 3 is being subtracted and the negative 5x is being subtracted. So just flip the sign on that one, flip the negative to a positive. And I got two like terms, so 6 and 5x are both x terms. So that would be 11x. Now you can kind of see that there's something weird happening here. And again, always be ready for weird things to happen. Okay, just like real life, you got to expect the unexpected. Okay, because in this case here, now you can see there is something weird going on here because I'm going to minus 11x. And like I always tell you, focus on the variable first, okay? Look at the variable because there are sometimes, it doesn't happen very often, probably happens like once every 30 problems, or maybe not even that many. But if you're looking at like most homeworks, like most of the homeworks that I've seen, it's usually about 1 in 50 to a 1 in 100 times that you'll get a no solution or an infinite solution. Well, I guess it really depends on the type of assignment, but in this case, I'm focusing specifically on equations like this or inequalities like this. It's about somewhere between 1 in 150 to 1 in 100. Wait, 1 in 50 to 1 in 100. Anyway, it's pretty rare, but it does happen. So that's why you got to check your variable first, because in this case here, I lose 11. So that means there's no variable, gone, a sneed. Okay, now in this case, we have to check it. Check the remaining statement. Is this true or false? In this case, this is true. But remember, true is not the answer. The actual answer we're looking for in this case is all real numbers. That's the actual answer that we need. Anything we put in there is going to work out. Okay, it's always going to balance out. No matter what number I put in here, I could put in whole numbers, fractions, decimals, negative numbers. It's always, this mouth is always going to be open towards the bigger side. So pretty much anything I put in there is always going to work. And again, this is different than no solution because no solution will never work. This one always works. So again, check to see if it's a without variables. Once the variables are gone, check it to make sure it's true or false. And in this case, we can pick something for interval notation because all real numbers means everything from negative infinity to positive infinity. All of that works out. Everything works. And now we've reached our last problem. Now remember, we have our steps. First step is to get rid of groups, which actually this one is a fraction, and a fraction is a group. So again, don't forget that either, because a fraction is a group. Because this is like a hidden parenthesis around the whole thing, but you don't see it, okay? It's there though. So I'm gonna multiply everything by -2. Now this side, I don't need to worry about it because it's already grouped. Here I have to put parentheses because W and 7 should be grouped, because I'm multiplying everything by -2. So if you remember those fractions where I say look at the bottom number and multiply everything by something that can be divided by that, in this case my bottom number is -2, so it'd be like everything's multiplied by -2, but then I'd end up having to divide it by -2, so I'm gonna end up right back where I was. So it's the same thing. It's the same step going on. Okay. Same step. And I'm going to double check it to make sure I did not forget anything, because sometimes I will lose the sign or forget to distribute or forget to multiply the sign, which in this case it looks okay looks okay to me for now. All right, so let's go ahead and combine our like terms, which in this case it looks like I do have 2 terms on this side that I can combine. So that'd be 4 minus 50. All right, now it looks like we have a pretty easy choice to make, because I would just add 2W to both sides. And since I canceled something on this side, I'm gonna have to cancel something on this side. (12W less than 46 minus 14). That would be 32. Now it looks like if I divide this, I'm not gonna get a nice number. So since I'm not gonna be able to get a nice number, I'm gonna have to work as a fraction. And again, if you wanna work, let's see, where can I put this? I'll put it right here, 32 divided by 12. This is probably the easiest way to turn it into a mixed number. So how many times does 12 go into 32? I think it's like 2 times, because that would be 24. The next number would be 36, which would go over 32. So we don't want to go over. So how much numbers are between there? So that'd be 6, maybe 8. Now let's see, 2 and 8 is the new top number, and the bottom number stays the same. But let's divide this 8 and 12. Let's simplify it. 8 over 12. So 8 and 12 can both be divided by 2, but it's probably better to go with 4. So let me put it right here. W less than 2, and 8 divided by 4 is 2, and 12 divided by 4 is 3. So 2 and 2/3, and this is the way you would write it as a mixed number. And because we're graphing it, mixed number is actually a good thing, because I can put 2 here. And again, it doesn't have to be in the middle. It just has to be included. So 2 and 2/3 would be about right there. Oh, and by the way, I forgot to mention this, but we can graph this, but I'm not going to graph that one. Well, I guess we could graph it. We could do something like this. Yeah, that kind of works out. But we'd need to actually fill that whole line in. But if you want to leave, if it's an all real numbers one, go ahead and leave it blank. Anyway, back to this one here. So W is less than 2 and 2/3. So pick a number less than 2 and 2/3. And you'd probably end up going this way. And if I pick 5, that's going to be false. And again, you can always plug it back into your original equation too, which I would suggest you do, because that's probably the easiest way to test it. So go back to the original, but this one's kind of a lot of work if I were going to plug it back in, which sometimes you just got to be ready for that. But in this case, I think I'm going to go with this here. Or is it because there is one thing that I did miss? And remember, the rule says if you multiply or divide by a negative. Now, if I plugged it back in, I would find out that it would actually be false. Because when we multiply everything by negative, which I just did, I multiplied everything by -2, that's going to cause this sign to flip. So that's easy to miss. Now, if that happens, that's actually going to change it to go this way. So actually, I should have checked it. Maybe I shouldn't have been so sure about it. But again, that's a pretty easy mistake to make. And, you know, I mean, if math were easier, mistakes wouldn't be made and people probably wouldn't hate it as much. So it is one of those things you got to be careful about. You got to kind of know what's going on. Anyway, let's go ahead and put it into interval notation. So I guess you should always believe in yourself, unless it's math. Okay. Anyway, there we go. So with all these problems, you got to make sure you do everything. Okay, so in your packet, there is a page that I call the rubric page. And that rubric page is how everything is done, basically. So how the grading is done, I should say. And one of those things it says is it says that you have to not only do the math part of it, you got to do the graphing if it tells you to graph it, or in this case, it tells you to put it in interval notation. You got to answer all the questions. All right, so make sure you do that. Last thing, now this is, I'm not going to require this, but this is what we call set builder notation, or just set notation. Now, I showed you these curvy parentheses that are called braces before, and they mean set. So in this case here, you would read it as the set of any x such that x is greater than 5. Now, for this assignment, I'm going to go ahead and let you just put the answers in like this. X is greater than 5, because it does kind of make sense. But I know in certain places, like a college class, you would have to put it in this notation. And that's exactly what it means. That's this x dash x thing. That's what it means. So it just means you can put anything in there as long as it's greater than 5. So anything greater than 5 will make it true. All right, so that is the end of this lesson. So